Hello, my name is Kevin Lay, president of Cascadia Composers, and for this month's May Composers Talk, we have as our honored guest is Rob Gándara, or do you say Gandara?
Gándara.
Oh, good, I
Gándara.
had it right. Rob Gándara, and his talk is Carbony Celtic Winds, Introduction and Demonstration. And I'm going to spotlight you. Thank you.
Okay, thank you, Kevin, for that beautiful introduction. I started making musical instruments um, in 2005. 2006 is when I actually completed one. So, but that's neither here nor there. My background is in manufacturing, so I worked for 10 years in the Boston area for Digital Equipment Corporation, which I was a product engineer for and a test engineer for a microprocessor, something called the PDP-10. And they were doing some different, the computer on a chip is what it was, and it was revolutionary at the time. And I was making sure that these units were made in a fashion that we can make money. So that's part of my background. For 10 years, I did that, and then I got a job in Corvallis, Oregon, to work for digital equipment. Excuse me, for Hewlett Packard, and they needed a manufacturing engineer to control their inkjet print cartridges and how when I came to Corvallis, every single inkjet print cartridge that Hewlett Packard sold was made in Corvallis, and they had this site was set up more as an invention spot, not as a manufacturing. So they were having to ship a lot of product that they needed help with. So in anything, it's always easy to build something once, or that's the discovery process. And then figuring out how to do it at the same time when you have to ship millions of inkjet print cartridges, that's more of the challenge. So that's where my expertise. I helped them establish a part tracking system so that if we had an inkjet cartridge that didn't work well, we could go back and just figure out it from a unique ID, what day it came off the manufacturing, what equipment path it went through. So if we had a problem, we wouldn't have to recall all the inkjet cartridges that were of a certain variety. I could say, oh, the ones that have problems went through, the laser ablation tool number 4 on May 1st and later. So we knew, gave us two things. We're able to only recall the parts that were questioned, that were introduced into the manufacturing line. And the other thing is that gave us the ability to go to laser ablation equipment number 4 and look at its, manufacturing logs and decide, oh, somebody changed the focus on the laser, and although the specs were being met, the diameters were correct, the shape of the nozzle wasn't correct. So that's why we were getting streaks on the printing on the paper when the drops finally came out of the little reservoir and landed on the paper. They were misdirected, and so we could go and figure that. I only give you that background because that's my background, and so I'm went through college as an engineer, and my background is in manufacturing, which means how do you design your products so that they're repeatable and manufacturable, and you don't have a lot of variation. Because if you can eliminate variation, then you can do a lot of heavy engineering work once, and then you have a very repeatable product. So taking that philosophy, if you look at a musical instrument, and I'm going to save this one for later. I'm just going to grab a simple one. And I don't want to say simple because it's a flute, and Casey will say that flutes are not simple. But I'm going to this is a flute.
They are.
And what's going on with it is this is an Irish flute, and in the middle of the 19th century, they invented something called a Bohm system flute, and that revolutionized classical flutes. And before that, what you had was what we call a Baroque flute, or now we call it an Irish flute or a wooden flute. We make ours from carbon fibers, so I can't quite call mine a wooden flute. But the old theory was, in order to get the octaves to line up, you had to have a tapered bore and a straight head joint. So the head joint would be not tapered, and the bore would be tapered at a rate. This is a replica of an 1859 Pratton flute, and Pratton was considered, at the time I got the plans from Terry McGee out of Australia, and he sold them to me, so I'm not like stealing his design and then working under the covers and trying to get. He gave me the rights to them for $100, and that's the culture we live in with a lot of trad music. There is some proprietary, but we all really want the culture and the music to continue. So, we do things above board, but $100 for the design of a perfect flute it's more just a nod of respect for both me to Terry and Terry to me, that we're sharing information, but that there was some work done to get there. But there's actually I looked at his numbers, and I found that there were 7 different tapers inside this bore, and so. Let me go back to the Bohm system. The Bohm system turned that on its head, and it has a silver flute has a taper in the head joint, and the body is straight. Now that works, but the only reason it works is because the tone holes are huge. They're so huge that you can't cover them with your fingertips. On a silver flute, you have these mechanical things on hinges that have little pads on them that are either cloth or leather, and they close the hole all at once when you push the lever down. Now you can get open hole silver flutes, but they still have a pad that seals the large hole because the hole's too big. So that's an artifact, or when the Bohm system got invented, that was how they kept it in tune as it goes up into the second and other registers. So that's a little bit of the physics behind it. As an instrument maker, physics is something that you always have to have kind of in the back of your mind. And there's in science, there's sort of there's the theory of the equations, and it's nice to be well versed with those. But then there's also you got to play it and see if it really works. So it's lost on my tongue the 2 terms for that, but there's sort of the testing, and then there's the empirical version of stuff. And so the instruments I develop have a little bit of both. I started out, when I started designing instruments, using a lot of equations and really trying to set up the ability to design something. So if someone gave me a fingering chart and say, I want these notes to play these frequencies, and I could use math to determine what the hole size, the chimney diameter, and the chimney depth and everything, and come up with what I would call a pretty good summation of what the instrument should be designed. But there's always going to be a fudge factor. So, this instrument is this long, so the wavelength with all the holes closed, you'd think would be where this opening happens to this tone, to the embouchure hole. Well, the wavelength actually projects outside of this a little bit, and it also goes up here a little bit more. You do have a cork that you can reposition to establish that, to change that. So there's always a little bit of testing or a fudge factor that no matter how great your equations are, you have to sort of retrain your algorithms based on humans being able to play it. Literally, if I can change the pitch just by rolling this thing in and out, so you have to kind of figure out where you're going to play it, and that affects the wavelength. Of course, we always have tuning slides to adjust for things like that. So anyway, the bottom line is this is a replica of an 1859 Pratten, and the numbers that Terry gave me, I did an approximation and a sort of a linear and parabolic and multi-factor approximation, and I came up with about a good approximation is there's 7 different tapers in here, and with 7 tapers, if you're working on a wooden instrument, you potentially go into this body with 7 different reamers with different tapers at different depths and come in and make all those adjustments. One of the advantages of building stuff out of carbon fiber is rather than having 7 reamers or a reamer with 7 different tapers, reamers, as you turn into wood, do machine the, take the wood off, but they also sometimes get a little dull, so you have to sharpen them. When you sharpen a reamer, it does remove some of the material, which does subtly over time affect the taper. So because the bore is what I consider so the bore is will set the basis of your intonation and the frequencies that any instrument is going to set. Another factor will be the wall thickness, or how thick it is. So you can see that, I'll take this flute apart just to demonstrate it. You can see on this end, so remember that this is turned back, so at the hole, it's actually closer to it's thicker. I had to turn this back to get this to fit on, but at this hole, the wall thickness is thicker. So you can see that there's some thickness here, and then there's some thickness here. I actually reamed the other end of this, so this isn't really a good visual for how thick the wall is. Needless to say, I know how thick each of these holes, how deep they are, and that affects the pitch. So you have the wavelength going to the first open hole. So this is a D, is with 6 holes closed. So that's the wavelength reaching here. And then the hole diameter matters as well. So when I lift this finger, it goes to the E. And the E is determined by how far it is from the embouchure hole, how deep this hole is, how far the air has to travel to get out of here, and then how wide it is. So a smaller hole is going to make the wavelength project farther down, and a bigger hole is going to release it more easily. So, and as you can see, the holes are all different sizes. That's because the other limitation you have when you're designing a flute is you have to be able to put your hand on it. So if we made all the holes the same size, the spacing would be such that I'd have to have alien hands or a third hand to come in and cover the holes. So by making this hole smaller, it actually moves it up the bore so I can reach it with this finger. And by making these 2 larger, they are going to actually be slightly down. Now, these Baroque or Irish or wooden instruments are all considered, so these are, I don't put keys on my instruments yet. This is something I can talk about later. I'm probably going to within the year, but I'm not going to discuss that. It's the major scale, major Western scale is so this would be a whole step, half step, whole step, whole step, whole step, and then it's another half step to get to the octave. So I think you guys are familiar with this is going to be a D major scale. If I can get the instrument to speak. So one of the things about this instrument is the holes are very far apart. That's how the instrument was really made. It does present challenges for some people. Some flute makers like Casey do some things where they rotate the holes. I can do that for people. That's not a big deal. He has other tricks that he does with to get the holes closer. There's something that I've been doing to get them a lot closer, and I'll show that on another instrument. It's called angled chimneys. Let's see if I got one here. Yeah, I think here's one. Yep, this one's got one. So I'm going to show you these two instruments next to each other. Okay, now this enables people who have smaller hands or are used to playing a silver flute to reach the holes. As a matter of fact, the center to center distance between these holes on this flute are actually the same as the center to center of the pads that you would have to close on a silver flute. So this is an instrument that if you come from a silver flute background, you're not going to have trouble playing, or at least reaching it. Now, the other thing I do want to mention is that you do have to cover the hole with your finger. On silver flutes, you can just flap the whole key down and it seals it for you. Having said that, it allows you to play in more of what we call trad style, where the articulation is generally not with your mouth, your diaphragm is not your vibrato engine. With trad music, we tend to slur everything, and you cut and you tap in order to articulate. So the part, and this is true of bagpipes as well. Excuse me, I might grab a little drink here in a second, just to keep my palate moist. What we generally do is vibrato is you'll do it by waving your hand over the hole, and that's not going to work on a silver flute. You can also do that on bagpipes too. The gaita is notorious. The gaita gallega, which is a Spanish bagpipe, is notorious for having a lot of vibrato with the hand. And then, so the part of your brain that operates your diaphragm now is operating your hand, and the part of the brain that operates your tongue, you can do taps and rolls and stuff like that. So I'm going to demonstrate that on a whistle just because it's a little bit clearer. So here's a whistle. It's in D. So the other nice thing is that the whistle and the flute, see how they both have 6 holes? If you're learning the whistle, you're learning the flute. Same number of holes, same notes. It's just this is an octave higher. And you can see that because it's twice as long. Or it's half as long as the flute. So... Okay, so rather than, I'm going to cut the note. And the reason we do this is because in Irish music, there's a big unison camp. So a lot of the instruments are all playing in unison. And when you play in unison, say with an uilleann pipe, uilleann pipes can't tongue because the tongue has nothing to do with the instrument. It's all played with your arm. And so an uilleann pipe will cut in order to articulate a note. And so if you're playing along with a piper or a fiddle or a whistle or a flute, and you cut in the same style, then you can sound like... The goal with a lot of these groups is to have everybody synchronized, playing the exact same note on pitch, the same rhythm, doing the same ornamentation, such that if you close your eyes, you don't hear a fiddle, you don't hear an uilleann pipe, you don't hear a whistle. The sounds all blend, and you hear this other thing, which is just this unison power of frequencies that when the band's really good, it gives me shivers anyway. So I mean, and the closest thing that I like to do in order to gain some of that is this is a drone whistle, and I'm not going to play 2 melodies on it. So I don't know if this comes across the microphone in Zoom, but when you play an instrument like this is a drone, and this one's going to be playing. This is a B flat drone, and this is a B flat whistle. Um, and I studied a little psychoacoustics in college. That was sort of my minor during. So not my at MIT anyway. It's not considered a minor. It's called a humanities concentration. And one of the reasons I went to that school is I hated English, and I figured out that I could go there and not take a single English class. You just had to take a diversity of humanities classes and then have a concentration in one of them. So I thought, oh, well, I'm just going to take a lot of music classes, which I did, and I got a concentration in music. I did end up taking an English class in American literature and read The Invisible Man, and apparently had an interpretation of one of the chapters that the professor had never even thought about before. And so I ended up getting an A, even though I was taking the class pass fail. But that's a whole nother story. But one of the things we learned in the psychoacoustic class is, so you know about visual mirages. So you might see water on a desert where there is no water. The lowest note that either of these tubes can make is the B flat. But if the harmonics line up, and this really comes to light in trad music, if you want to compare just intonation to even temperament or equal temperament. What happens if harmonics line up? And so the harmonic series is there's a fundamental, and then if you double that frequency, I know this is review for a lot of composers, but I just love to talk about it. The next harmonic is the octave, and then that's twice the frequency. The third harmonic is 3 times. So if you got nodes here, this is the first sine wave is like this. Let's see, you got node here, node there. You got a sine wave like this. The second one is like this. The third one is like that. It's actually the fifth. It's approximately the fifth in even tempered. So you have a frequency, twice the frequency, 3 times the frequency, and then 4 times is the second octave, and then the fifth harmonic will be the third above that, approximately on a piano. If you really want to talk about what the frequency is, that third harmonic is actually sharp of an even tempered fifth. And so one of the nice things about this instrument that I compose a little bit on it. So there's a plug for anybody who's a composer, because I can feel the harmonics. And if you want to compose a just intonation melody, this will get you in that mind frame. What happens is if I play this B flat and then I play the fifth above it, so B, C, I usually talk, so for the fifth above D is an A, the B flat is B, C, D, E, F. Would it be a G? Anyway, B, C, D, E, F. F, yes, F, sorry. Sorry. Forgive me for that. But if you put an F next to a B flat, the human ear will hear the B flat below that because the harmonics line up, and it's an aural illusion. And I hear it in my brain, and if you were to play this instrument, I don't know if you can hear it across the microphone. And then if I play the fourth, you get a different lower tone that lines up with it. Anyway. Ooh, I hear a ooh right there. But when they line up, your brain will actually create. And so one of the experiments we did, and we listened to, I forget which piece it was, where there were just violins playing, and then when they hit these notes, you could hear a note that would probably only be available on a cello, and yet there was no cello scored on that part of the so it's a fun thing to play with. I'm gonna get something to drink. Here is strawberry hibiscus sparkling water.
So, Rob,
Yes.
I have a visitor who just showed up, so I need to sign off here. So it's great to see you.
Thank
So
you.
I'll
Thank
catch
you.
the rest of the talk on YouTube.
Thanks, Keith.
Perfect. Thank you, Kevin. And I'm going to take a little break while I'm enjoying this strawberry hibiscus sparkling soda
Okay.
and check in with people and see if there's any questions or anything I went over a little bit too quickly or something that you'd like for me to go back.
I had one quick question about your work at HP. Did you know? Do you know Bruce Reed?
Yeah.
Yeah, he's a musician up here in the Seattle area
Oh,
who was
wow.
part of the development of the inkjet printers.
Yeah. I would say I was at HP during the magical time, from when it was like a brand new invention and no one could believe that we were selling that many printers around the world to really getting our act together and then of course
Yeah,
shipping all manufacturing overseas. So
yeah. So did you know
I
him
had
in that
mentioned,
context?
what's that?
Did you know him in the HP context?
Yes, yes, yeah,
Cool.
exactly.
That's cool.
I mean, I've played music my whole life, so we might have actually been in some. We might have watched each other play music at some point. I only got into Irish music after I moved to Corvallis. I was playing
Yeah,
other music before,
yeah.
and actually did take a composition class from John Harbison, if anyone knows him. A classical composer
Cool.
who was doing a thing at MIT, and so I was taking classes from him, which was fun.
Cool.
So,
Well, great to see you, and I'll
yeah,
catch the rest on YouTube. Also, I have a book to send you. This is an announcement. I just heard from my friend Montserrat Gascon, who's one of the researchers on the La Claude Laurent glass flutes. The English version of her book, which I helped edit, has just been printed, and she's sending me a bunch of copies. So I'll make sure that you're on the list.
oh yeah,
So
I'd love to, yeah.
yeah, it's an interesting book, and that the keys that were mounted onto the glass, that kind of method would work probably with your flutes and stuff.
Yeah, I'm
So
still exploring the best way to mount keys. I think I have something that's going to work, but I want it to be super cool and unique. So,
right.
I'm shying away from posts, and because of how I mold the carbon fiber, block mounting is I can't do it the way you would do it in a piece of wood. But I
Right.
think what I'm going to end up doing is going to look a lot more like a block mount. But
Uh-huh.
I don't want to get I haven't done it yet, so I don't want to
Okay.
talk about
Okay.
it too much.
Okay.
So
Well, you take care,
thank you, Kevin.
That's good.
Casey.
So the general break. How's the direction of what I'm talking about for people?
Oh, yeah, this is fantastic for me. I'm
Okay.
totally eating it up.
Okay.
Yeah, I appreciate it.
Oh,
And I,
that was Casey. That was
that was
Casey
Casey.
leaving. I'm
Yeah,
sorry. Yeah. Yeah.
yeah. And it's kind of interesting how you just kind of the undertones you use for saying, oh, by the way, I studied with John Harbison. That totally spurs me. My God, what a great composer Harbison is. Wow.
Yeah, no, he really opened my eyes to opera.
Hmm.
I took an opera class from him and had no idea who he was. And during that semester, by the end of it, I not only knew a lot about opera, I knew a lot more about John Harbison. So,
Yeah.
yeah, he's very humble and understated too. So he's just it was a class of maybe four people. It was really I didn't know how special the semester was, and I saw him once since then in Eugene. He did a thing at the at the shed, they call it down there.
Mhm.
Um, and you know, everyone was trying to talk to him, and he's, you know, after the concert and everything, and then I just kind of just waited my turn and said, yeah, you know, I took a class from you back in the class was called Music in 1984, the state of classical music and opera, how it was. Is it dead? Is it demise of music as we know it? And you know, people are still asking those questions, but I mean, I've got my Portland Opera tickets, and we go all the time. So um, it was a joy to have his perspective on all that. So anyway,
Yeah.
John recognized, he pulled me aside later and was really gracious and made time to talk to me. So that was, even though, you know, 30 years later and stuff. So,
Oh,
um, but
wow.
yeah, he's a great guy. Um, and I hadn't thought about him in a long time, so it just kind of comes up. So one of the things I did want to talk about is one of the revolutions, or way I've revolutionized Irish flute and whistle playing, is making this instrument much more playable for people with smaller hands. And the way I accomplish that is, so traditionally these holes are just drilled straight.
Mm.
And for years I had been drilling them at a little bit of an angle, and that will gain you a millimeter or two, because the bottom of the holes, you know, here, and you're drilling the hole here, but it wasn't doing a whole lot to make the instrument more playable. Um, and then I had the revelation to not just drill the hole at an angle, but to epoxy in a little chimney or a tube inside, so that makes the bottom of the hole, makes the chimney longer, which means that you can it's making it longer without having your finger to reach farther, but it also um, brings it, makes the air turn a corner and come back towards you. So it really enables me to make the spacing whatever I want on these instruments. And just so you can see what it looks like on the inside, let's see if I can. So I don't know if you can see, there's a little nub
Yep.
on
Yep.
the inside of that. I'll turn it around.
So that one's not a
So
very deep chimney, right? Or is that?
no, this one isn't. It looks a lot more pronounced on the whistles, because these are thicker walls, so most of the chimney is being covered by the angle. But on the whistle, you can really see it. And I sell probably a lot more of these than anything. See, for flute players, they can always play a silver flute, so that they get too
Oh,
frustrated. But
yeah,
on
look at
whistle
that.
players, you can only play. So you can see a little bit more of a.
Yep.
See,
A chimney.
there we go. The chimney is, yeah. So you can see,
Hmm.
maybe it's. There we go. There's a better picture. If you go on my website and look at either the flute or the web or the whistle page, there's a pretty good drawing of how it looks. Um, and why don't I see if I can sh share that page right now?
Something
So
I'm
I'm going to.
interested in, and it's just in general, is the carbon fiber material itself is like, do you lay it down in, I mean, it
Yeah,
looks
and so this is
so structural.
where I was going to, that I wanted to talk about. Let's try this. Okay, let's see what happens if I do this. Um, there we go. I'm screen sharing. There's my email with the connection, and then I'm going to go to Carbony. There we go. Can you guys see this at
Yeah,
all
there.
yet?
Yeah, it's really slow though.
Okay.
I don't see your screen actually. It just
Okay. Now it's gone. So I don't know what happened.
hmm,
Um, let's see what happens if I do this. Okay.
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 Let me remove the spotlight. Maybe that's what it needs.
I don't want to log in. I just want to go to carbony.com. Let me get the page up, and I think that will.
Hmm.
Okay, there we see. Okay, there we go. This is a good screenshot of it if I can. So let me do this. Share. Okay. Let's try. There we go. Try that. Does that?
It says you
Can you?
started, but I don't see it doesn't show the image yet. Oh, there it is. Got it.
There it is. Okay. There I have a photo of the two flutes. The bottom one is the traditional spacing that they made in 1859, and then the top one is the the one that I make, and then you can see the drawing up there above it. So you have a little chimney that goes in at an angle. Your finger only has to reach to the top of it, and then the acoustic resonance goes to the bottom of it. It's you know, what's nice about my material is that tube that I use is carbon fiber, and so I sand it and it bonds to the carbon fiber that that the instrument's made out of. So, and it's the same epoxy. So comes with it's a very durable process. Like I said, I come from a manufacturing background, so I wouldn't introduce this as a product if I felt they were going to fall out all the time. And to the naked eye, it doesn't look like there's anything going on. So it's all internal to the bore, and so no one knows that you're playing a cheater, so to speak. And then what I was going to before, and I'm sorry, I've kind of let me see. How do I get out of this now? We're going to say no sharing.
There's usually a stop sharing key at the
I got to
top.
stop sharing. Yeah, I got to. You are now screen. Oh wait, recording on this computer. You are screen share. Stop share. There we go. There we go. And I'm back. Hooray! Thank you for your patience. So rather than sharpening a reamer and reaming a piece of wood and then waiting for it and then reaming it again, because wood is kind of alive and it has to dry out, and then the final shape isn't really something you get when you initially machine it. I machine down the outside of a steel mandrel, so that will have if I need 7 tapers to make this instrument, I have a steel mandrel with all those tapers, and I send that out to a precision grinder down in Southern California, and they grind it to my specifications, and then they ship it back to me, and then I pay a lot for that one mandrel, but that one mandrel has preserved inside of it all the different bore angles that I need to make an instrument that's perfectly in tune. So what I'm trying to say is I spent a lot of time making the first instrument correct and in tune, and then because I have a mandrel that I wrap the carbon fiber around, the carbon fiber, I use something called pre-preg. It comes by the yard, and it's 0.2 millimeters thick. So there's a very simple equation, 2 pi r is how much material you need to wrap around it in order to get one wrap. The next wrap needs to be a little bit bigger because you've just changed the radius by 1 wrap. So you can know your initial diameter of the mandrel and your final diameter of the carbon that you want, and then you take the average, and that tells you how many wraps you need at 0.2 millimeters of thickness to get to the desired diameter of what we call outer diameter, or OD, of the instrument. You know what the ID of the instrument is because that's going to match the mandrel, and we use compression tape, and it's actually really accurate. So, I will wrap it using this equation, knowing that what I'm wrapping is 0.2 millimeters thick. So I have very precise diameter on the inside of a very precise finish diameter. I do some sanding, so I take about 0.1 millimeter of the surface down when I do the work to finish them. Now, something like this normally I turn this back with the lathe and then put O-ring grooves in it. That's something else I can do that you can't really do with wood. Is with wooden instruments, you either have a piece of cork or you have what we call hemp, is sort of the older, more traditional. And then, as the wood expands and contracts, the cork will wear out, or you'll have to take hemp on or take it off in order to get the parts to fit. With the carbon, it doesn't absorb moisture, it doesn't change temperature, change shape with temperature or humidity. So I can take an O-ring tool and cut little O-ring grooves and install O-rings on this that are the exact diameter I need, and then this will fit no problem. So all my joints are done with O-rings. Some of the reed seats, because a lot of the reeds I do not build reeds. I don't build them into the instrument. We use traditional reeds that you're going to get from someone who makes reeds for wooden instruments, for big bagpipes and things. So they all come with hemp. So I do put a threaded reed seat on all my bagpipes so that you can use more traditional reeds to fit in there. I used to have another reed interface, but that meant that you had to get all your reeds from me, and I'd actually prefer having the flexibility of my customers being able to try whatever reed they want and not having to lock them into just something that I have available. So so there is hemp associated with putting the reeds in, but not with the instruments themselves. So I build the mandrel once, and I get the same bore, and if I use the same layup, I get the same exterior, and so I'll spend a lot of time drilling these holes and playing the instrument. If it is using the empirical data, I can make a refinement, and then once I've had it all documented, we have a drill press that's accurate to 1/2 of an inch, and we use carbide tip drills they aren't your regular drill bits. They look more like tridents, and so when you're drilling on something that's round, you go with something that only has a point, it's going to want to walk. It's going to go to the left or right. So a good way to avoid that, and I don't want to give all away manufacturing, use more of a trident drill. The center point will touch down, and it makes a little divot, and then rather than regular drill bits start in the middle and then they drill out, so you get a lot of chatter with that, you get a lot of noise with that. If you have a trident dip, we're not actually cutting all the fibers as we get bigger. We're using these two parts of the trident to cut just the edge of the hole, and we get a much more repeatable hole doing that. So once again, these bits are more expensive, they're carbide tipped, but we've optimized our processes and our equipment, and it saves us a lot of time and energy. So it may say, oh, you're paying extra for all these bits, but it actually saves us long term because we're not cutting all the fibers. We're going in with the trident and we're just cutting a disc. So when we're done cutting, there's usually a little disc that has a little center hole in it, and that is ends its way on the ground or up our vacuum system, because we do use vacuum system. That when you work with carbon fiber, you have to, you don't want to breathe it. So it's inert. So if you swallow it, it's okay. It's carbon. It's the same molecule that's in trees, and we are carbon life forms, but the particles aren't good for your lungs. So anytime we do a drill operation or something, we usually have a vacuum system attached to it, so all the airflow is going away from whoever's doing the drilling, and it goes up into a vacuum. If we're doing something like a saw, we use a wet process, and that creates sludge. So we just flood the saw with water as we cut, and that also is the dust particulate that you need to avoid. The carbon sludge, it's inert. You can grow plants out of it if you want. It's not a big deal. It's not going to really fertilize them, but it's not going to hurt anything either. It's more of a filler than anything else. That's a little bit about the manufacturing process.
You mind if I ask another question?
Yes, please.
It has to do with the nature of the material. I mean, I know wood, and as anybody would know,
Yeah.
but can you compare a carbon fiber to a regular wood fiber? I mean, as far as brittleness or
Yeah,
hardness or how that
and
works?
that's a great question. One of the things, so that there's, if you look at the physics of sound, sort of, if you don't get into just, if a tube's this long, it's going to produce this frequency, and the second harmonic's going to be twice that frequency, and the third harmonic's going to be the fifth above that. And so the material you use to get the intonation or to get the frequencies is a lot of physicists will say is irrelevant. You're going to get the resonance. But there is sort of a timbre quality, and when I say timbre, I don't mean wood timbre, I mean the timbre of the sound, that I can play a wooden instrument and you'll know immediately it sounds different than a metal instrument. One of the things I do, and this is just from an approach to using carbon fiber, is I dial in the density to match that of wood. And then something else I do, I just want to talk about, is just the layup we use. So on all these instruments, the thicker they are, the more carbon's involved with it, and actually the more wood they're going to sound. The thinner they are. So a metal whistle metal is amorphous, plastic is amorphous. It doesn't have a structure. There's not really. Carbon fiber has a fiber structure, and one of the things we do is the very first layer that we put on the mandrel is what we call like a weave. And what that enables us to do is when the drill goes through, so when you drill wood, if you're drilling tone holes in something that already has the bore established in it, you need to put something inside the bore so when the drill breaks through, it doesn't splinter and ruin the inside of the instrument. So a lot of times, in some techniques of pipe making, they start with the square block that they haven't done the bore yet. They'll drill the finger holes and then go in and ream the bore later to avoid any splintering. So another way to avoid the splintering is to have something supportive inside that matches the taper of whatever you're doing. And so when you drill through, the wood is supported and it doesn't splinter. Now, the way we get around that with carbon fiber is the very first layer and that I lay on the very inside of the instrument, and you can see it. Maybe if I can get that to focus on this, you might not have enough light to see it.
It's shiny.
But anyway, it's a weave,
Huh.
so that when the trident drill bit breaks through, it's not going to splinter because there's cross patterns there. So it's only, if it's going to splinter, it's only going to splinter to the tightness of the weave that you have. And so I will go in there with a little file and just clean up that edge, but there's never much to clean up, and it's usually done really easily. You could probably even do it with a Q-tip if you, because the fibers are so thin and fragile there, it's not hard to clean it up, but a metal file works really well. So the first layer is always going to be carbon. And then when I'm building up thickness, I'm trying to get more of a thicker wall, I use something called unidirectional. And if you look at a tree, all the fibers are parallel. That's why when you look at a tree and it's a windy day, the limbs will bend. A tree doesn't do cross layers. If it did, it would be stiff and it wouldn't bend in the wind. So my philosophy is to try and make this material as wood-like in both, in every aspect I possibly can. So I do have to use a thin layer of weave as the first layer, but the bulk of what you're looking at here, and on these instruments, this is unidirectional on the outside. So you can see there's no real weave in this at all. So and that means all the fibers are going parallel this way. And so what that means is you have something that most of the 95% of the fibers are all parallel and they're all in the same direction. Even on this instrument where I put a weave on the outside so it looks like carbon fiber, all the interior layers are all unidirectional. That's really important because what that does is that will reinforce the low harmonic. So that's one of the reasons wood sounds very different than metal, is because the higher harmonics are dampened. You have fibers that are running the length, they're 24 inches long, or this is 23-inch long instrument, so maybe the fibers are only 22 inches, but they're wanting to be at that frequency. They deaden the higher harmonics. And if you're ever in a carbon fiber kayak versus like an aluminum one, if you ever wonder what the actual reality is of being in a fiber instrument rather than an amorphous boat or whatever,
Right.
is if you're in an aluminum kayak and you tap on it, it just goes thunk. But if you hit a carbon fiber one where it has continuous fibers running the length of the boat, you feel the vibration throughout the entire boat and it all resonates as one. So one of my goals is, and one of my big points to people is that they play these instruments and go, wow, that really does that's surprising. It sounds like wood. I wouldn't think that from carbon fiber. Well, it turns out carbon is the main molecule in trees. Carbon's the same molecule. Trees have fibers. These have fibers. If I orient the fibers so most of them run the length of the instrument, you're going to get very similar vibration properties. And the other thing I do is they've always made, pipes, bagpipes, and a lot of the wooden flutes have always been made from the hardest wood that they could find on the planet. So, when there was a time when the sun never set on the British Empire, and so you were getting pipes made. Today they're made mainly from grenadilla, maybe some ebony, but we're still looking for the hardest wood we can find. I can dial in the density of the carbon fiber to be a little denser than even African blackwood. So it's about 5% denser. It won't float. Carbon is that dense. That doesn't mean that if there's not air trapped in it, it wouldn't float, but eventually that air it'll sink to the bottom. So what I'm trying to say is my goal is to have the structural fiber layout of the instrument match wood, to have the density match wood, only vary from that for a good manufacturable reason, being that I don't want it to splinter. When you get to real thin layups like this instrument, where that's 1 millimeter of a wall thickness, you pretty much can't mix in a lot of unidirectional because it won't have the structural integrity. So on an instrument like this, it's all weave because it's only 5 layers of material, and that's what gives it the lifetime warranty. But the thinner the wall is, the less the material affects the resonance. Now this is still going to sound a lot warmer than a metal whistle, but it's not doesn't get nearly the resonance that the thicker whistles that I make. So I'll just play this for you. And this is an octave lower. It just has a richer sound. And I'm going to grab a metal whistle here so we can do a head to head. And you'll know exactly what it is I'm talking about. And that compared to a carbon whistle. It's just got a rounder sound, and that's because of higher harmonics. So a lot of people say, oh, Rob, your whistles aren't real loud, and that if you look at them at a dB meter, they actually have very, very similar volume because a lot of the geometries are borrowed from metal whistle equations. The difference is they're not shrill. The high notes aren't piercing, the higher frequencies. So it kind of changes the instrument, and it does. Some people say it's soft, it sounds softer, but what it is it's less cutting. So in some ways, I like to tell people it's like, there's some very high quality metal whistles out there made by Michael Burke, and Copeland made some beautiful whistles out of metal, and there's MK. I mean, there's all kinds of metal whistles out there. They're always going to have a different sound than this, so it's not uncommon for a professional whistler to have one of my whistles and have a metal whistle, depending on what it is they want to do. Are they going to a session where they want to be heard above all the fiddles and the uilleann pipes and everything else going on? Or are they in a studio trying to record something to make, someone cry because it's a tender melody and we're just trying to move the heart? So, musicians are bad like that. They want a different instrument for every type of, and composers I could see doing that. The difference between a flugelhorn and a trumpet to the untrained ear but ask Chuck Mangione, God rest his soul, and he'd tell you all about it. So, but that's the whistle. The flute has always been made of wood. It's always supposed to be made of wood. You actually have some softwood versions of it that are going to be even a little warmer than this. This is supposed to be your workhorse hardwood flute, and that's the market that I've targeted this instrument for. And bagpipes are also made out of wood, so I'm going for the hardwood bagpipe that has the better projection of sound and also stays in tune. So.
Wow.
So I've talked a lot, and let's open it up for a couple questions, or what direction you guys would like me to go next. I think I've talked a little bit about the material and why I've chosen it, and that was a very good question about how does it compare to wood. My goal is to have it be wood, so wood is going to be temperamental in temperature and humidity, and if you had an 1859 Pratt and wooden flute, you probably wouldn't travel with it. You probably wouldn't play it outdoors at music festivals, and you wouldn't bring it to a session because it's something that you maybe only play, in temperature controlled environments and your what are those in your study or your reading room or your library. But anyway, so these are one of my goals is to make instruments that people can travel with and carry with. They do come with a lifetime warranty. I always tell people that I live what I preach, and I travel around the world and go to music festivals. I just had a hip surgery, so I'm not traveling right now, but we're going to Germany this summer, and there's a Rudolstadt festival that I've been doing for over 10 years now. And everything goes in the luggage, and knock on wood, I've lost luggage, but I've never lost an instrument. Baggage handlers have torn up my luggage, and I've had to buy luggage, but I have a packing technique where I put the instruments in padded bags inside the luggage, and never, knock on wood, never lost an instrument. And so
You mentioned that you get instruments ready for performance. Sorry, my voice is hoarse. And I'm wondering, like a conductor doing any certain type of music would do you think the conductor or a composer would want to hear different resonance? But will the conductor, depending on the type of orchestra, recommend or suggest or ask for a flute that is wooden or copper or the fiber? Sorry, it's almost midnight here. Carbon fiber, or metal. Would
yeah.
How versatile is that, and how is it ever requested from, say, a conductor?
Yeah, that's a great question. So, right now I've been these are considered Baroque style flutes. So you will have some conductors who want traditional Baroque tuning, and I've done different tunings. One of these are it certainly would be something that I know some of my bagpipes have been played in ensembles for that very reason. That the carbon fiber projects a little bit stronger than a wooden Scottish small pipe or a musette. I think some of my instruments have been used instead of a musette just because the projection was a little bit better when you're playing with an orchestra. Um, One of the things that I do is I build whistles in different keys, which is also a throwback to, what Baroque music used to be like. You would need an E flat flute to play something in E flat because there wasn't always, because one of the things I try and preserve with these instruments is just intonation. So the third on my flutes is going to be a little flat. That doesn't mean if you're a skilled flute player you couldn't lip it up. And the fifth is going to be a little sharp, and the seventh is it's probably the one I have to fight the most. It's closest to equal. It's not as flat as it would be, like on a bagpipe. The seventh is usually really flat, and it just doesn't. It's hard to play regular music outside of the key when you do it that much. So I have a nod in these instruments to just intonation, which fiddles can do, in spades because they don't have frets. And it's so a conductor or a composer may ask for a specific instrument to get a particular sound. One of the big differences between these flutes and say the classical flute is when a classical flute player picks up a flute, notoriously, I've been to the National Flute Association convention. It's going to be in Portland this summer, so you'll see me there. They try and see how high the instrument can go, and they're really the first octave is kind of a throwaway octave that's not really used in composition very much. On Irish flutes, we're designing this instrument to get the most power out of the lower octave and to try and make that low D bark. So it's called the foot tone, and we are designing the whole bore to get a big performance out of those lowest notes, because that's where Irish music lives. And a composer who wanted that sound would need to have actually specify a wooden flute or a carbon flute or something. I don't think anyone's gotten to the point where they specified a carbon flute, but they're going to need an instrument that is geometrically designed to play the low octave and be loud down there. And the silver flute just isn't. It's not something that people, they want power out of a flute at those octaves. They'll go to a bass flute or an alto flute or you don't hear that note coming out of that size of an instrument regularly. But it's a great question, and I think what I do know is that there's some Baroque compositions when people are trying to recreate music from the past. They will ask for period instruments. I am looking at developing some flutes from the Renaissance and Baroque eras that you have to have the whole set though, and so I'm still working on that, but it's something I'm dabbling in. It gets a little tricky because people who are wanting to be very exact about what frequencies were played back then also tend to want to use wood that was existing back then. So the question is it a lucrative market is a whole different question, but I can replicate any of those instruments without any problem, and they'll sound very close to like they would have back then, um, with as much information as we have about them.
Yeah, and on Native American flutes, we had a project a few years ago writing Native American music, and I wanted a flute, but I really wanted a sound that I really couldn't hear anywhere. So that probably would be a similar type of thing made out of a certain type of wood, and uh, Yeah.
Yeah, yeah, and there's a process that Native American flutes, usually they burn the holes rather than drill them, and that it's a piece of wood that is local to the area. Um, and a lot of that is the mystique, and it does lend to the sound. Having said that, I've made this isn't one I made. This is just a Native American flute we have here at the shop. And it's just a different scale. It's not a Western scale. And you can
Nice.
adjust the volume by moving this piece up and down. It's the holes are generally equal space, but it's not a Western scale. Um, but having said that, this isn't made from a piece of wood that's locally sourced, and it's not. The holes aren't burnt. They're done with a drill press. But if you're looking for that scale to be able to play notes that would fit in that modality, I've done it in carbon fiber, and it has a different sound, but this is a higher pitched one.
Mm.
And the trick is, in order to get that sound, you want it to be very expressive in the lower octave, and you can't. These other instruments are all designed to play 2 or 3 octaves, so there's a compromise. The Native American generally plays 1 octave, so a way to simulate that is to make the bore much bigger, and that the human breath can only generate so much pressure, so you're not actually even able to get to the second and third register on these instruments because we can't generate that much pressure. But what that allows you to do is be more expressive in the first. So the first register. So if I was to change my breath pressure that much on one of these other instruments, it would automatically jump to the second octave. So, so the physics of this can be replicated in carbon. It still wasn't made, wasn't blessed by anyone, and I'm just saying that I'm able to make those notes and take sort of the design specifications of this being a very large bore and match it up to something that I have available to make as well.
Amazing. Boy.
That's cool.
Yeah.
Wow.
Boy, it sure, Kevin, isn't this fascinating? It
It
just,
is. It's amazing. And
yeah.
really, really, really
It's
great.
like, I want to write
Oh.
music with that, with that sound.
Yeah, I know,
Yeah.
and I'd love to be part of a project. I had someone call me today, and this is kind of, I've been doing this for 20 years, and my goal at the beginning is I'm a product engineer. I never really thought I would be building stuff. I just thought I'd develop a technology and just raise my flag and say, hey, anybody want to build instruments out of this? I can kind of got it figured out. But then the proof's in the pudding. No one wants it because they don't know it exists. So you have to kind of make it exist before people know that they want it. And I had a wonderful call this morning. The guy had sent me an email saying, oh, could you send me a tube that's this geometry and this? And it's like, well, I get people wanting to make their pet peeve instrument or pet instrument for them all the time. But then he called me and said, no, I need to know what you're doing and what's going on. I really like your stuff. And he's actually a silver flute maker who's wanting a head joint out of carbon and is serious about using my processes and techniques and refining it so that he can introduce a head joint that's pure out of carbon. And it's like, oh, well, that's kind of what I thought I was going to do 20 years ago. And instead I went on this thing where it's like, well, I have to prove that this is an instrument worth material worth building instruments out of, I can't just tell people that there's no reason they're going to believe me from Adam. So anyway, I just kind of weird that finally today I got a call from someone, and I was just like, I've been out of that mode for so long. It's like, oh well, this was originally part of my business plan back in the day, but
Yeah.
so there you have it. It may become more, as more people experience these instruments and play them, I may have opportunities. I used to play clarinet, or I still do play clarinet. I mean, I'd love to make a clarinet out of this material. I think it'd be awesome. Um, but I'm not going to compete with Yamaha right today and try and but if someone from Yamaha was to approach me and said we want to try it out, I give them, we'd sign a contract, but
Yeah.
we could come up with a carbon fiber clarinet that might actually be quite nice.
And that is when I met you on the plane. You were coming back from California. I mean, from Germany, from the clarinet concert. That was one of your instruments.
Yeah, I was at it was actually an anniversary of one of my retailers who makes a lot of bagpipes, and well, just I mean, you mentioned the clarinet. I'm just going to show you an instrument that I made for one of my customers. This is something that, say, has a sax mouthpiece on it. Could have a clarinet mouthpiece on it, but it's just easier to make because with sax mouthpiece you have a cork there, so I can take any sax mouthpiece and fit it to the instrument. But
My
this was an
God.
instrument originally made out of plastic, and it's called a Highland hornpipe. And when I ran into one a long time ago, and it said patent pending on it, and then someone contacted me and said, "Hey, my plastic body broke. Can you just make one out of carbon fiber? Because I think it's really cool." And so I looked at it and I said, "Well, I can make you one, but it says patent pending on it, so we have to call it a repair. It's not. I'm not going to be able to monetize this with anyone else. So this is the price you're going to pay and stuff." And he was okay with that. And I made some refinements. It wasn't actually. It was just kind of thrown together. And so I made some changes and I gave him one. And then just after I'd done it, I said, "Well, let me look up that." Patent number and see where it's at, and apparently it had been abandoned. So this instrument that used to be made out of plastic, that fingered like a bagpipe, had the sax mouthpiece on it. When a patent gets abandoned, that basically means it's public domain. So I'm able to offer this product as an instrument, and people can
That's
buy it
great.
from me. I can't patent it. No one can patent it now because it was abandoned. So, but that means it's public domain, and so
And
that
just a brief question, because I know it's getting late.
yeah,
Bagpipes. I worked at Interlochen Music Camp, and
yeah,
they have these little bagpipe orchestras, and we have one, and here in Port Huron, Michigan, we have this humongous sailboat race, and they send the boats out by size and category and so on. It takes like 2 hours to get them sent out, and they have these bagpipe orchestras. And I think, why do all these bagpipes sound so good? I mean, it's not just a loud
right,
blasting. It's so your description of your instruments, I know, it's the way they're made, and of course the way they're played, but I did the Scottish country dancing. If we had one bagpipe leading us into the dance, that was it just brings tears to your eyes. But
yeah,
to have a whole orchestra of bagpipes doing this, it's like um, I just think it's amazing that type of unique instrument that can be so many people playing it at the same time, and it just sounds so rich and good, you know.
Well,
But
thank you. Yeah, no, I get chills up and down my spine, especially when my instruments are played, but just whenever I hear them in general, which is kind of why I got into it. I mean, I didn't grow up playing Celtic music, but I did play a lot of classical music. I played jazz. Was in a punk band at one point. But I really was drawn to Celtic and Irish music because you can play it in a pub. Um, and it's a participatory sport. If you go to a session, everyone should you're encouraged to bring an instrument and join in. You know, it's not something that is just a spectator sport. Um, and you don't have to be angry at a man to go to a bar and play it for people.
yeah.
In punk rock, you always had to have some kind of angst or some reason to get up and be motivated. Here, you can just enjoy the music for what it is, which
Yeah,
is
yeah, yeah.
Wow.
Boy, I sure learned a lot.
Yeah, what a
oh,
it's a great way of summing up the evening.
I thank you guys. I didn't know exactly where I was going to go or what I was going to talk about, and I'm sure in a different mood and a different time and different people, I would have talked about something totally different. But I appreciate your patience and
Oh,
your
yeah.
audience, and I don't know if it shows, but I do love what I do.